A warm welcome to Module 5 in our series on parallel and intersecting lines. Today we are going to explore corresponding angles. In our previous modules, we examined how a single line, say L1, intersecting another line M gives rise to four angles at the point of intersection. These angles are beautifully interrelated through two key concepts. Given a single angle 50 degrees, we can find the angle right across it. Why? Because these angles are vertically opposite and they are equal. But not just one, we can find the other two remaining angles as well. Can you guess why? Because they form linear pair and they can be easily found by subtracting the given angle from 180 degrees. So these angles will be 130 degree. Remember, the angle sitting right across 130 degree again is a vertical angle, so they are equal. So the conclusion is that when two lines intersect, two pairs of equal angles are formed. One set is acute and the other set is obtuse. If you are uncertain about any of these foundational ideas, kindly visit our previous modules. Let us now take this a step further. But before we do that, let us call this one the first point of intersection. We copy line L1 and place it right below, creating a new line L2, such that L1 is parallel to L2. What happens now? Four more angles are formed at the second point of intersection. While the angles at the first point of intersection are sorted, the real challenge arises when we have to find the four missing angles at the second point of intersection. So we try to move or rather leap particularly from line L1 to L2. But how do we bridge that gap and determine the missing angles? To solve this, we need to identify any one missing angle at the second point of intersection. Once we do that, the remaining journey is a familiar, repetitive one. What do we mean by corresponding? Think of it like matching pair of gloves. They may be on different hands, but they are identical in shape and position. Similarly in math and specifically in the angles that are formed by intersection of parallel and intersecting lines, we will look for the position or the placement of angles with respect to the two parallel lines and the intersecting line, that is the transversal. So we'll be looking if the angles are lying on the parallel line or under the parallel line. Are they lying on the right of transversal or left of transversal? Let us explore further. Observe the two red angles. Are they both lying on the right of transversal? Exactly. They both are on the right of transversal. That means they are sitting at the similar location. But are they sitting at the exact same position? For that, we will explore the parallel lines. Are they both sitting on the parallel line? Exactly. Both these angles are on the parallel line. That means they are sitting at the corresponding position. Such angles are called corresponding angles. And if the lines are parallel, it is easy for us. If any one angle at any point of intersection is given, we know a copy of it will be lying on the other point of intersection at the exact same location. Because the lines are parallel, corresponding angles are equal. So we've explored one set of angles on the right of transversal, which are acute pair. Let us observe the other set. Can you see the blue angles? They both are lying on the right of transversal. But are they lying on the parallel line or under the parallel line? They both are lying under the parallel line. So they are sitting at the exact same position. That means these two are corresponding angles. Observe how they are obtuse. So if one angle is 140 degree, a copy of it will be sitting at the second point of intersection. Does the same logic apply on the left of transversal? Observe it carefully. Two angles are sitting on the parallel line on the left side of transversal. So if one is 40 degrees, the other is also going to be 40 degree for the same reason. They are corresponding. Let's explore the obtuse pair on the left side of transversal. Both are lying under the parallel line. So if one angle is 140 degrees, the other angle is also going to be the same because corresponding angles formed between the parallel lines are equal. Let us now put everything together. So when two parallel lines are intersected by a transversal, two angle pairs are formed on each side of the transversal. And in these two angle pairs, for example, you are seeing angle C on the screen. One pair will be acute and the other pair will be obtuse. You can observe how angle D is obtuse, how angle A is acute. See, the overlapping that is being shown on the screen signifies one important aspect and key property in geometry, that is they are congruent, that means they are equal. So we have 8 angle pairs, 4 are acute and 4 are obtuse, and angles in each pair are equal. If we compile everything that we have discussed so far, you can think of it as if the entire structure at the first point of intersection has been copied onto the second point of intersection, as if each angle has a twin in the same relative position at the other point of intersection. This is the essence of corresponding angles. They are mirror images of each other. Observe these angles on the screen. Observe the position of yellow angles, the pink angles, the green and the blue angles. See how they are exactly the same. Also, draw the conclusion that in these angle pair, if one is acute, the other is obtuse. So that means if one angle is given to you, you can quickly find the other by subtracting it from 180 degrees. Can you find a pattern or a shape that will quickly help you to identify the corresponding angles? Yes, corresponding angles can be identified by looking for an F shape in the parallel lines. In the given question, we have been provided with one angle 70 degrees and we need to find the 7 missing angles. The first thing that should come to your mind is that out of 8 angles, 4 are going to be 70 degrees and the remaining 4 are going to be the supplement. That is, we simply have to subtract 70 degrees from 180 degrees. That means we will get 110. So the 4 acute angles are 70 degrees and 4 obtuse angles are going to be 110 degrees. We must now figure out which angles are 70 and where are they located. So just look across 70 degrees. Which angle do you see? Angle 3, and this is going to be 70 degrees. Why? Because they are vertically opposite angles. But what about the other 2 angles in the same point of intersection? They are going to be our obtuse angles, that is 110 each. For the simple reason they are supplements, or as we call them, they are linear pairs. As soon as you find all the angles at one point of intersection, you just have to create its mirror image at the other point of intersection. And yes, you've got all your 8 angles because of corresponding angles. Observe this question, pause the video to match your learning pace and find the missing angles. So, the angle right opposite this given angle is 65 degrees because it is vertically opposite, and the remaining 2 are going to be the supplement of 65, that is 180 minus 65. So the 2 angles are going to be 115 degrees, and all the 4 angles at the other point of intersection are going to be a mirror image. Hence we found all the angles, and the reason we will write is corresponding angles. Stay in the video till the end to dive into the rapid fire round and show off your math skills. I am now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you.